Thank you. Welcome and good morning. I'm Felix, Principal Engineer, Spark at Microsoft. I'm also Apache Spark committer. Oh. Okay, we're having some problem here today. We're going to be fun. So I've been contributing to Spark and SparkR for almost 2 years. I also co-organized the Seattle Spark meetup. And I was a teaching assistant of the massive online course back in 2015. And it doesn't work. Okay, there you go. For today, we're going to talk about SparkR. We're going to start with a quick introduction of SparkR. For those of you who may not be familiar with it, I'm going to talk a little bit about how it works and so on. And we're going to talk about what's new in SparkR in 2.0 and 2.1 releases. And then we're going to dive into SparkR for data science. How that works, what are the options, trade-offs, challenges, and so on. And we're going to wrap with touching on the ecosystem and what's coming in Spark upcoming releases. And it's not working. Okay. Okay, so today is all about Spark and the laptop and without the clicker. And before we start, I want to do a little bit of a disclaimer. What I talk about today won't be possible without contribution from Bill and other people in the community actually working on R itself. So, to begin with, here's a 5-second overview of Spark. Hopefully you're already familiar with Spark, but if not, it's a general purpose computing system, multiple different language binding, supporting different types of workload, machine learning, a graph, and so on. And here's R. R has been around for some time. It's based off this predecessor. S has been around since 1975, which is really, really long time ago. One thing I do want to highlight is really rich ecosystem. CRAN repository has just celebrated 10,000 packages as of a few weeks ago. So this is a really large set of community and contribution and packages and that you can leverage and build rich data science related kind of application on top of R itself. We're going to talk about how we can leverage that using SparkR. So we're going to put together Spark and R together. And here we have SparkR. So what is SparkR? SparkR is a R language APIs for Spark and Spark SQL. It exposes Spark functionality in the R-friendly data frame like APIs. It has this REPL, and it could be actually loaded as a package onto an IDE with basically 2 lines. All right, high-level architecture. So SparkR essentially is 3 separate components. So we have a set of R classes and methods that you can call into, and these are the APIs that, we're building an R application, this is what you call into. There's an R backend, which is communicating between the JVM and the R process using a proprietary WebSocket protocol. And it has a set of Scala helper functions, so wrap around things like the ML pipeline and so on. One thing I do want to bring your attention to is what you see on the right-hand side, where we have the worker and executor, and each of them has a companion R process that works with it as well. The advantages of this architecture is that most of these processing is actually kept inside the JVM process. This benchmark is from 2015, so it's a while ago, but as you can see, taking advantage of Catalyst and all these innovation happening in Spark SQL and Spark Core itself, SparkR is not really that slower or faster than any other language binding you have. So what do we support in Spark and what do we support in SparkR and what's new in SparkR? We already support SQL, Spark SQL, transformation, SQL query, support data sources, anything that is Spark support, we support. In Spark 2.0, we have a new concept called Spark Session, and this is the first time ever where we have R bringing in the new language binding, supporting Spark Session in the same release as anybody else. And then we have this unique concept called Spark default session, in which case you call into the Spark API without having to specify the current session itself. So make it simpler for our user to call into the Spark APIs. We also have support for catalog APIs for managing external tables and so on, support for Spark packages, and something called Spark add files, which allows you to specify a set of files that get distributed to the cluster itself. So you could use it for distributing a locally installed R package to the cluster without having to actually go through the cluster management of it. And then we have ML and native UDF support. We're going to talk more about these two things in much more detail later on. And the very last thing is we support it's the same 3 cluster manager, just like the rest of Spark itself. Okay, so we're going to talk about SparkR for data science. Okay, so you have to have a big data set. Some of the things you need to consider is, can you use existing SparkML APIs for processing it? So if you can go through the right side of things. We're going to talk about how our SparkR has implemented a pipeline model, and we wrap around it, and we actually give you rich functionality based on that ML pipeline model. If you have a favorite kind of R package that you want to use, you can also use on the left-hand side, which is how we're going to be able to kind of distribute your data set and execute your favorite R native package in parallel in a distributed kind of scalable kind of manner. Oh, I don't think a kicker is working. So unfortunately, we've already tried. Oops. Wow, there's a lot of things not working here. So that. So the remote, what? A little bit of a technical help maybe? It's not moving. Good idea. The Bluetooth is fighting me. That's fine, I'll just, we're okay.
Okay.
All right.
Can you get back to your
Yeah. All right. A little bit of a distraction here, unfortunately. I think I'm finally giving up on this. I should have done earlier. So a quick introduction of SparkML Pipeline. So what it is the whole point of ML pipeline is the notion that when you're building a machine learning model, you oftentimes need to perform multiple different sequence of operation and transformation on a data set before you can run your machine learning model on it. An example of this is where you see it below, which is you take your text, you want to tokenize it, you want to hash it up before you can pass it on to maybe a classification model that you want to build. So for things like pre-processing, feature extraction, feature generation even, and then you're running it through your model, and then doing validation and performance evaluation, that sort of thing. So we have the same sort of support in SparkR. So we're running a little bit behind, so I'm going to kind of go a little quicker with the technical difficulties we have. But to give you a concrete example of this, so here we have Spark LDA. So with what you see on the left-hand side, you pass in the text as a parameter. You specify k and multiple number of iterations and so on. What that translates to on the right-hand side you see on the JVM is that we applied by default the sequence of transformation for you already. So it passes through the regex tokenizer to tokenize your text. Apply stop word and remove the stop word, and then we do the count vectorizer at the end, and then before passing it to LDA to generate your model. There are other model operations that we support in this case. In general, you can get a summary of the fitted model. You can make prediction using new data coming in. And then you can also persist and retrieve the model at a later time. The main difference here is in R, we also, in addition to the pipeline model that get persisted, we also have additional R-specific metadata that we store. That's helpful for generating the same model summary that you're used to in R. So in Spark 2.0, we have a total of 4 machine learning models, which is a lot, right? In 1.6, we actually have 1, which is GLM. In 2.0, we have 4. But what I really want to show you is in Spark 2.1, we have 13 machine learning model and algorithm that you can run. So in addition to GLM, naive Bayes, k-means, AFT survival model, isotonic regression, GMM, LDA, ALS, MLP, KS test, multi-class logistic regression, random forest, and gradient boosted tree. What's unique about this SparkR implementation of SparkML is the notion of R formula. R has this notion of formula that you can use to specify your model in this symbolic form. An example of this is what you see on the top, which is Y is to respond modeling linearly by F0 and F1. So you can specify your label and your feature, in this symbolic form, which is really handy. And in SparkR, we support a subset of it, what you see here. And what's interesting about this R formula support is this is actually implemented as a feature transformer. What that means is you can actually use this R formula support in other language binding as well. So we've seen people actually using it in Scala. You can use it in Python if you wanted to. In addition to supporting the model specification, there are additional benefit of using this is there are kind of default transformation that's done automatically for you. So you have a label column that is a string that automatically get indexed as you specify them. And then if you have term columns that are also string, it will automatically get one-hot encoded. So here's an example of GLM. We started off implementing GLM using the exact same signature that you're familiar with in R. That's what you see on the top. Same parameter, order, and so on, what you already familiar with. But as we implement this, we realize that there are additional parameters specific to Spark that we don't actually have in R. So we have a second implementation of this called Spark GLM. Has a slightly different parameter order, but specifically there are additional model parameter you can specify in calling this function. Another example here is Multilayer Perceptron. You can see here the layer and the number of nodes in the hidden layer you can specify using a vector, which is very handy. And then we have multi-class logistic regression. Here what we have is we have multi-class logistic regression that is similar to what you get from GLMNet in native R. And here's my favorite, random forest. In random forest, we support both regression and classification. And then we have GBT, also supporting regression and classification. And for classification, we support binary classification. And I want to give you an example of the number of parameters that's actually supported. So the early example, I give you a really simplest kind of example of how you can call those API. But if you look at the documentation for these API, you can see there are a number of options that each of them has the default value in it. So you can optionally specify them if you wanted to. And then also expert level parameter, as you see at the bottom here, that's kind of you can tune if you know what you're doing. Some of the challenges with SparkML, we have limited API set. It's non-trivial to actually map the SparkML API into the R API because we're building a sort of a simpler abstraction on top of the underlying pipeline model, a transformation, underneath. And then it's actually challenging to keep up to all the changes in ML itself by kind of having these additional R APIs around them. Fortunately, we almost kept up with all those changes here. We have almost every single one of these machine learning model except for run versus rest, which is challenging by itself because it allows you to specify different types of classifier as we go. It's kind of hard to figure out what is the right model that exposes in R. And then we have a little bit of a trade-off where you can't specify the additional transformer you want to apply to the pipeline model. So this is something that we're tracking right now. We're actively thinking about how to take this forward. And then as with any kind of non-JVM language binding, it is kind of challenging to debug Spark from R itself. This is not a ML-specific problem. But we have already made some progress on this in terms of unwrapping some of these exceptions and error in the R side to make it more friendlier for our user to understand what's going on. So moving on quickly, we talk about using the ML API, which wrap around a pipeline model. Another approach you can do is you can actually call your native packages using the native UDF. UDF is a user-defined function which you can use to apply custom transformation on it. There are two approaches you can use. You can apply it on a per partition basis or a per group basis. And the idea here is with UDF, you take the R native data frame, pass it on to UDF, and then we expect to get back a R native data frame back. The approach we have here is if you're processing it by partition, what it does is for each of these partitions you have for your data set, it automatically get serialized and passed to this R companion process where your UDF is reciting and processing that data set. And then we take the returning data.frame, native data.frame, and serialize it back to JVM at the end of it. So the advantage of that approach is instead of doing it by row, this is more efficient because it's applying it on a per partition basis. In terms of how this works, this is an example of dapply, where you can specify the data frame, which is first parameter, specify your function inline. You can do your transformation there. You do need to specify a schema, which we're going to talk about, the data type mapping, so that we understand what actually is being returned from the native code. Another example here is you can do dapply collect, in which case you don't have to specify the schema. And in the end, you get the native data frame. In this case, it's not a Spark data structure, it's a native data frame at the end of it. And here's a more elaborate example, dapply collect. So you pass in the data set, and then you can specify this function inline. Here, I'm actually calling the native random forest package. And then we take this data set, and then we generate a set of prediction and returning that as a data frame at the end. One thing I do want to highlight here is this T. This is one of the lesser known features supported by SparkR, what we call closure capture. So T is a native data set. What happened here is this native data set, this test set, is automatically serialized and broadcast to all the executor so that it's available when the UDF is executed. So it's really handy that way. And then we have the apply by group option as well. So here we have the Spark data frame. You can specify one or multiple grouping columns that you want. And in the UDF function, here's an extra parameter called key, which is the grouping key that you can use optionally in your transformation itself. Another option is dapply collect, which is similarly with dapply collect, where you don't have to specify the schema for it. Here's an example of the data type mapping. We have bytes mapping to Spark byte, numeric in R mapping to double, character to string, and so on and so forth. So we have pretty much all the mapping and all the JVM types supported by Spark in here. So some of the challenges with UDF, one of the things that we don't actually support is struct. So the idea is if you have a nested data frame with nested structure in it, we don't actually quite support it in SparkR today. And then there's a challenge of scaling up and data skew. So as you distribute data, remember we were talking about the data set is divided into partition and so on. It's a pretty common thing when it so happen that your data set is not evenly distributed, for example. If you have bigger, a lot more data in a particular data set, in a particular data partition, then you could run into a problem where there's a lot more data going in a particular R process. And it becomes even more trickier when you try to do apply it to a group, because your grouping could be fairly granular. For example, if you are looking at United States and divide it into metropolitan area and so on, and a certain metropolitan area has a lot more people than other ones. So you get more data in those groups as opposed to the other ones. So it's important to actually look at your data set and understand what's the best way you can apply those grouping in calling these functions. Obviously, like I said, you can specify additional grouping. You can do some feature generation. You can apply additional grouping columns to mitigate this problem. And you also have the flip side of the problem, which is as you divide the data into group, there are certain native classification packages, for example, that will require at least some variation of the data set. So at least two categories in this group of data before it could perform that classification for you. So if your data is not just so happen distributed that way, then you might run into the problem when you call those native packages that you may not have enough variation for that model to work. In addition to these challenges, you also have the additional performance overhead associated with this approach. There's serialization, deserialization costs, and data transfer between the JVM and the OWL process. So very last thing here, in addition to dapply and gapply, there's also lapply. This is very similar to lapply in R. It's good for embarrassingly parallel tasks that you can do. And the way this works is you can take a vector, and individually each of these elements you have in the vector and list can get passed into the UDF. And then at the end, your UDF can return almost anything that could, anything you can think of. And that get returned as a list to you. So here's an example of how this works. So at the very top, we have a series of cost value that we generate. And then we call spark.lapply. This is the function at the end. And then we have this function that we define separately this time. And in this function, we're calling SVM. So what this is doing is it takes this native list of cost value, which could be a much larger, and parallelize the processing of it, and apply that UDF along the way. In the end, we're returning a summary of that model. So what you can do is, at the end, you get the sets of summary. You can evaluate the performance of that model, which cost value actually is performing better than anything else. One thing I do want to point out is what gets returned could become pretty large because it needs to fit into the drivers. So if you have a lot of data returning, your model is very large, that sort of thing, or you have a very large number of cost value and things that you want to parallelize and process on, it might not fit. So it's something you need to be aware of. Okay, so here's a walkthrough I have collected. Let me just restart this. I don't think that's working, so. All right, so I have SparkR loaded as a package. I call SparkR session, loading the session. And then I can check the configuration using SparkR conf, right? You can see all the configuration that is set up for Spark. You can look at the help that we added recently on this. It's a getting start guide, basically, with example how things works. An example you can use or try it out. You can know your data set. I'm calling read.df, print schema, looking at the schema of this, looking at the sample subset of data, register the temp table, running SQL query, double check that the numbers actually matches. I can run even more complex SQL query, with group by and so on. And this one is a more complex one with ordering, group, and all these things, computing average and so on top of that temporary view. And here's a sample of that. And you can also build a histogram on this. So, and then you can plot it. So let's take a look at what it looks like. Here's a data set. Wow, okay, so seems like so this is flight data, which is kind of just in time for something today like this. So you can see more delay in the afternoon. Huh? So anyhow, so you can also use a package called Migrator, and then you can do pipelining using is a built-in support, where you basically take your data and then pass it along. And then I can also generate additional columns. Based on these criteria I have, added 2 columns, whether this is early or at night. And then I can split the data into multiple training set, cost validation, and so on. Doing dapply, calling the native random forest function on this. This is basically the sample that we look at already. We have T, which is also a native data set that get passed along using closure capture. This model runs. And then you get some sample data back, and as a result, I'm doing a head on the data itself. So that's it. So here's basically how this works. And we're going to switch back to the slide here. Okay, and one last thing. So one thing we've been working on, we're really looking forward to, is having Spark as a package on CRAN as well. So right now we're targeting Spark 2.11 release. We've tried a few times. There are a few things that we've been sort of working on to make sure all the issue has been addressed. But the goal here is having a regular R user and can go in and just use a single line, call this single line, and install SparkR as a package onto his laptop and his machine. This is actually what Matei said yesterday, in the keynote session, making it a lot more accessible for a regular R user to try it out on their machine and having the same setup that would scale on the cluster level as well. What's interesting about this is after you do that, the R package will automatically download the Spark release from the official release share and then install it and cache it onto your machine itself. So you don't have to worry about anything about the JVM side of things. You do need to have Java though. And we added additional help and online help and getting start guide and things around this. The goal here is we're hoping the community can actually write additional packages. That depends on the SparkR package as we go forward with this. And to support this, we actually added a few set of these API. This is unique in the sense that it not only talks to the JVM process, but it actually talks to the specific Spark JVM process. So you can use it to call into Spark context, things that are kind of Spark core and internal that's not actually exposed, which could be useful if you're an expert user or you're writing a packages that you want to access some of the internals. And in terms of ecosystem, you're probably going to hear more about this. There's an RStudio Sparkly R package. There's also RX Sparks, which actually works with the R server as well. There's the HDO R package. And then there's a bunch of other R-related big data processing system there. And to recap, SparkR 2.0, we added Spark session support, ML, much richer ML machine learning models, and we also have UDF support. But what's coming in Spark 2.11? So in Spark 2.11, we fixed a number of bugs related to GLM and LDA. We added the partitioning support for data frames. So it makes it easier if you're working with native data set. To start with, you want it to be already partitioned the correct way before you start joining with other data set and so on. This is kind of what we added to support something like this. And we added a really helpful shortcut for setting columns. So you can set literal value or actually transform another column and then setting it and adding as a new column. We also added API for getting access to the Spark URL APIs, so you can actually get the URL and click on it. You can see the job and understand what's going on in there. And then we added more error handling for the install Spark function, which is used when you're installing Spark as a package. So what else is coming in SparkR? So in 2.2, which is hopefully the next minor release for Spark, we already added bisecting k-means. This is already check-in. We are looking at a set of machine learning related improvement, whether we, for example, what I said about supporting ML pipeline or richer R formula support. And we're really looking for comment and feedback. If you're an R user, if you're new to SparkR, welcome to comment on these Jira issue or connect with me, give me the feedback, and we will actually really welcome feedback and contribution for all of these as well. So that's it. Thank you. And I'm looking at hopefully fielding some questions.
Let's give him a hand.
Thank you.
That was great. Yeah, we have a couple minutes for questions, so I'll just scurry around here and help people out.
Hi, this is Jamal speaking. It's great. I have a question about Bayesian networks. Do you have any plan to? We have a package named BNLearn to build Bayesian networks.
Mm-hmm.
I'm just wondering if you have, and it's not scalable.
Mm-hmm.
Do you have in your plan in the future, like to build something like could be distributed? And
so
scalable?
Is it a native package that you implement in R?
That it already exists. BNLearn, like for Bayesian
mm-hmm.
networks. And I'm just wondering if you could
So as far as if I understand your question correctly, so we have Jira out for different types of Bayesian network that we're thinking about integrating into Spark itself. There's a process in place. Joseph is doing a great job of figuring out what we want to commit to for the next upcoming major minor release for Spark in terms of ML itself, not SparkR specific, but ML itself, what should be included in Spark ML. So feel free to reach out to me later on, and we'll figure out what the Jira number is. We can kind of follow up on, where you can kind of get provide more feedback into what should be included, what would be really useful for that, something like this. Now, if this is supported by Spark, what we're committing to is if Spark is self-supported, we want to make sure that SparkR also supported, within the same minor release, if possible, if not the one after, basically. So this gives you the capability of actually, like, as soon as we have this enrichment going into Spark itself, that would be surfaced up in the SparkR as well. So this is kind of what we have in mind in terms of what we're looking at. But this is an excellent point. I'm also help shepherding basically all the ML related kind of Jira and plan around what we actually are looking into for the next minor release and so on. So we're looking at 2.2 right now. So this is now a great time if you want to actually get your feedback in what would be good to incorporate into Spark itself. But having said that, there's also a rich kind of list of packages already out there that is running on top of Spark, leveraging data frame for the optimization that you can building on top of things like the ML pipeline and things like that exists as a Spark package. So I mentioned there's a repository of about 300 packages that you can find already that are easily integrated with the Spark pipeline, not specific to R, but like overall in general. So that could be another route you could say, hey, I could easily quickly iterate and build packages that run on top of Spark and my own machine learning that's specific to kind of what I need and make it really easy to distribute and leverage, in my environment and so on. So that's something you want to consider as well. So. Yes.
Great, yeah. So I think we're actually at time here, but Felix is very responsive. Like, he's been great in sort of helping me and coaching me through pull questions, that sort of thing. And so I'm sure he'd be happy to take a couple minutes, but let's just give it up for Felix again.
Thank you. So feel free to reach out to me on LinkedIn, or if you see me around on GitHub when working on these Spark, Jira, and pull requests and so on, feel free to ping me there. And thank you.